So welcome everyone to today's Harvard Data Science Initiative Industry Seminar. I'm Jen Chow, I'm Director of External Engagement, and I'm delighted to introduce our speaker today. Ram Chandra is Director of Customer and Marketing Data Science at Toyota Motors North America, where he's responsible for and accountable for expanding the customer data science programs that deliver business solutions and driving data-driven decision-making through data science adoption across multiple business initiatives. Ram's career has spanned various e-commerce retailers, building customer loyalty models, evaluating marketing effectiveness for sales and upper funnel conversion goals, making recommendations based on product analytics, and forecasting product demand. He received his master's in structural engineering and a bachelor's in civil engineering, both from the Indian Institute of Technology, Kanpur, and has numerous certifications in machine learning and deep learning. Before we get started, I'd like to remind everyone that we use Zoom's Q&A function to take questions, so please feel free to add your questions during the talk. Thank you, Ram, for being with us today, and please take it away.
Yeah, thanks, Jen. Thanks for that introduction, and it's a pleasure speaking here. So yeah, I created a slide, but probably won't go into the details because you kind of covered it. So this is a little bit about me. I'll just talk about one specific thing about myself. Most of the learning that I've had is actually from the on-the-job development. I've done a lot of certification, specialization, but I also built my career during a phase when there was not a lot of academia around data science. So a lot of stuff that I've actually done is on-the-job development, something we call OJD at Toyota. And yeah, Customer 360, Dealer Market Tool, Loyalty and Engagement, Opportunity are those some of the bigger programs at Toyota that I built. So today, what I thought will be useful for you all, if we talked about Toyota a little bit, we talked about data science at TMNA, and then we talked about how to go about doing customer journey with data science. And we'll keep it in such a way that it's not going too much in the technicalities, but feel free to ask any questions that you might have, and then I'm happy to answer. So with that, let's talk a little bit about Toyota. And yep. So our story has always been about let's go places. We're in the business of making great cars and trucks, but we also work every day to apply and share our know-how in the ways that benefit people, the community, and our planet in order to build a better tomorrow. Right? So that's our motto. The way we work is to create some of the most advanced and reliable and safe vehicle. That has always been the focus. And it starts with a lot of our manufacturing principles and management philosophy, which I'm going to touch upon a little bit. And we're a company, we always like to improve our operations, right? And that's also part of our management philosophy that we have. And yeah, always looking to collaborate, always improving each day and everything we do. So it's not a statement, but it's something that has stayed with Toyota for almost 4 or 5 decades. So it's the same principle, it's just that we continue to adopt it across different business functions. Our US history started in 1957 with Toyota Pet Crown, and then by 2021 we had built 30 million vehicles right here in the United States. We have sold close to 60 million vehicles in the US alone in this period. And this is a number that we have from last year, basically. So we have been 35 years in manufacturing in the US. We sell close to 2 to 2.5 million vehicles. This is a COVID year. We have these many people working across the US, across the value chain that we have. We have 10 plants. We have 1,500 dealers. We have obviously, I mentioned about 30 million vehicles built in the US and counting. And we almost close to 500,000 jobs that we created in the US. I won't go into too much details here because these are all public information. I've put the link so you can actually look at it. But let's talk about Toyota Bay for a bit, right? I mean, a lot of people know about Toyota, but Toyota Way is the management philosophy that we have at Toyota, and it's basically 14 principles that helps us to do anything. And the pillar for all the principles is around two main pillars. You can almost say that there is a respect for people, and then there is continuous improvement. So everything that we do at Toyota is actually driven based on these pillars. And the reason I talked about it today in a data science talk is because when I present you some of the slides later, you'll be able to relate a little bit. There's a very fine book on this. So if you're interested, you can actually go through that. I'm not going to go through all the principles, but I'll touch upon two important philosophy, right, which has been researched outside Toyota. Also, there are a lot of other companies who have also implemented it. So there is something called TBP. We call it Toyota Business Practice, and it's basically concrete action and processes that exist for problem solving. And Toyota Way are basically the values that help us drive and achieve these action processes. This product, we have training for over 8 hours to go through the TBP, where we teach different steps of the TBP and have everyone do a TBP in their first 90 days or first 6 months of the job. But this is a way of problem solving, basically, at Toyota. There's another concept called JKK, and it means built-in quality with ownership, which basically says that if you're doing anything, then you have to make sure that you're able to develop an optimal work process of the work. It might feel like that it's relevant for manufacturing, but we have found that JKK, when implemented across quality, marketing, customer, different areas, it still holds good, right? And the foundation of JKK is such that if you're able to establish your workflow, right, then you're able to improve it, right? If you're not able to establish your workflow, or if you don't know the steps involved in your work, then you may not be able to improve it over time. So that's the reason JKK is important. And this is how JKK and TBP works. So if you don't have a standard, you sort of develop a standard, that's JKK. If the standard exists, then while working according to the standard, if there are a problem that occurs, then you sort of solve it using TBP, and then you refine the standard, right? And this process continues, right? So this was the other pillar that I showed in the last slide, which is talking about the continuous learning. It's also called kaizen. It's a Japanese term. So these are some of the concepts that we talk a lot at Toyota, like across business function. I'm not gonna go in a lot of details there, but it's core to what we do. And then let's talk about data science now. So before I go and talk about data science at TMNA, let me just talk about the different business functions that we have. Some of the key business functions. I mean, there are a little bit more, but let's understand what TMNA is consist of. Like, there are other Toyota companies as well, right? So it'll make things a lot more clear in terms of what TMNA is responsible for. So we are responsible for vehicle engineering. We are responsible for manufacturing. We are responsible for demand and supply. We are responsible for logistics, so that we have the vehicle built from the plant, sent to the dealers, so that the customers can go and then just buy it. We're responsible for all the sales and marketing that's happening across US. We're responsible for all the quality issues that exist, improving the vehicle, and the quality and the vehicle engineering and manufacturing, they work very closely. We are responsible for all the after sales, so all the dealer operations. So when you go for service, parts, if you need a subscription for Toyota Care and things like that, then those are all part of TMNA itself. And then we are responsible for our dealers, right? We couldn't do anything without the support of the dealer and amazing dealers that we have. So we have so many business functions, right? I mean, so it's going to be very hard to do data science across all these business groups. So what we have really done in data science team, we have sort of created a hub and spoke model, right? A model that exists like in a lot of companies. So nothing new. So our central data science team, we have different pods, which are taking care of the needs for each of these different business functions. But then the team, the pod are the core team. But then these different business functions, they can have their data scientists, they can have their analysts who are working in close collaboration with these pods. So that has been something that has been working for us for some time. And we continue to invest in building this core pod for our data science so that more and more businesses can take advantage of that, and also complement in some ways to those teams, and so that we are continuously building solutions, building the backlog as needed, those kinds of stuff. So this is what exists. Let me just go a little bit more into the pod, what a pod consists of. So any data science pod, they'll have a product manager, they'll have a scrum master, they'll have a data analyst, they'll have data scientists, data engineers, ML engineers. So these are the different roles. And obviously based on the amount of backlog, a product manager is able to judge how many roles I'll need for, how many people will need for, let's say, a data analyst or a data scientist and things like that. Similarly, if you have another pod, it'll have a similar structure, but it is possible that we have a scrum master who is shared across pod, but none of the analysts, scientists, or engineers are shared across pod. We try not to. Some cases there are some overlap exists, but mostly we tend to keep them dedicated to a pod. And then it's possible that a product manager might be responsible for multiple pods. So a few years back, I was just sort of responsible for multiple pods. I still am responsible for multiple pods, but then they have their own product managers. So this is a structure of the pod. Let me just go talk about the delivery aspect, like how do we deliver? And one of the other important philosophy that we use is PDCA at Toyota a lot. PDCA means plan, do, check, and act. So being agile and being delivering based on a Scrum team require you to have really good roadmap and a plan for the work that will be happening. So this is how we go about. We sort of, as a part of the planning, the goal is to create a delivery roadmap, right? But how do you do it? You sort of have your strategy, you have your theme or the product that you want to build, and then you decide on the feature. So these are the work that's happening between the stakeholder, product owners, and the product managers. Once they have settled down at a feature level, feature could be, hey, I want to build, let's say, a loyalty model, which would help us understand the customers in a way that we can position our Toyota Care more appropriately, right? So that could be a feature. But then the work is not done by product manager, it's done by team. So there is a lot of discussion that happens between the product manager and the agile team along with the scrum master, so that they sort of create epic stories and appropriate subtasks as needed. And the idea is that from a top down, you have a delivery roadmap, and bottoms up, you have the epics and what's needed to achieve this roadmap. Again, this is again consistent across many teams. Within data science team also, we tend to follow this. Um, so I'll quickly switch gears and talk about data science. So this is all about how the team is, what roles we have in the team, how to go about creating roadmap. But let's talk about even thinking about a data science use case. Like how do you even think about it? And how do you ensure that you have the right skills in the team and right needs, so and the right technology to actually go and solve any problem. And there are many ways to look at it. One way I obviously showed you the business function wise. You can take a look at that, but within a business function itself, there can be a variety of different use cases. And you can say, yes, there is a segmentation use case, there is a personalization use case, and so on, right? But even more general, if we were to take a look at the use cases, this is how I tend to look at it. So you start with data, right? You start with data. You see, you have a lot of structured data. I mean, we have built over the last 30, 40 years. I mean, not at just Toyota, like everywhere. We have built a lot of databases, right? It means that you have a lot of structured data. Then you have a lot of time series data, things that are just stamped at date level, day level, minute level, and so on, right? So you have a lot of time series data, right? And then you have a lot of text, right? It has sort of exploded in the last 15, 20 years, right? You have a lot of images and videos, right? And then you have audio. And obviously you have like a lot of waves and other stuff as well. But if you really think about 99% of the use cases in data science, it can be categorized under one of these categories. Obviously, there can be use cases which will have an overlap, let's say, between text and image. It is very much possible. But if we have to simplify it and look at the use cases, this is probably a good way to categorize it. And I'll go into more detail why I say what I'm saying right now. So if you see the structured data and the time series data sets, whenever you have a use case around these data sets, you're basically trying to either do prediction or you're trying to get some insights out of these data, right? But when you're dealing with text, images, or video and the audio, you're mostly trying to automate a task, a human task, something that a human can do, but you're trying to automate it, right? Obviously, I mean, you can use text, images, and audio to even predict out the future, but I'm just talking about a general use cases that you would come across. It's related to automation. And obviously, I mean, you'll have insights that'll overlap across both. So what it tells you that from a value perspective, you can get instant value from some of the automation that can happen using text, images, video, and audio. But for structured data and time series, it needs to have a very strategic use case. If you're going to be predicting something, then you need to know how it'll get utilized, right? And that's key, because oftentimes data scientists are told to build models, but they're not told how it'll get utilized. So it's important to understand the difference, even from a data scientist perspective, right? I mean, if they know, if they're working on a text classification model, they should know that it's sort of trying to automate something that a human might be doing today, or they may not be doing from any one perspective, because it's just too much effort to do manually, right? You take example of surveillance. I mean, you can have a lot of people actually looking through the camera and do stuff, but then you can have a detection based camera which can automate that stuff, right? It's all automation. So if you look at TMNA, we have use cases across all of these types. You have Structured use cases, like you want to try to predict customers who could be in market. You're trying to segment customers. You're trying to use vehicle data to see some of the diagnostic issues, some of the predictive maintenance stuff, marketing mix, churn, loyalty, attribution of marketing efforts, right? Time series, sales forecasting, demand forecasting, right? But how do you do budget allocation, part sales forecasting, scenario planning, right? A lot of those things are like out there in future, but based on time series data. Text, we have done text use cases. It's so easy nowadays to go and complain about any issues on different social media channels. We have surveys where we try to collect information around our products, how well it's been doing, and that has been the basis for introducing customer voice and building quality, right? You'd want to understand where the issues are, where the concerns are. That's related to product. It's related to our dealership. It's related to something, new needs, right? So you have a lot of text-based use cases. You have image-based use cases as well. Imagine detecting at the paint line on assembly line. If you'll be able to detect issue with the paint itself, that's a huge use case because it takes a lot of money and actually effort to remove the paint and do it again, and it all needs to be in a very controlled setup. Process detection, you can have someone missing a certain part of the process, some object detection, something that was not supposed to be there, or something that was supposed to be there but it's not there. You have audio use cases. You have engine noise diagnosis. Imagine you take your car at the dealership and they sort of use a device that can detect an audio and can tell you what are the kind of issues that this kind of noise would mean. You have brake squeaking kind of stuff. Not all the use cases are actually done, but these are the different use cases that we have at TMNA across the different data types. And obviously there are many more. There are many more across many other areas, and there are many more that are overlapping as well. But this is just to give you an idea about the kind of use cases that we have at TMNA. So let's talk about data science process. We talked about team, we talked about a use case. So if you really look at industry, this is what everyone talk about. You have crisp BM method of building a model. That start with business understanding, data understanding, and all that. And this is another one. This is from Microsoft right now. So it says, let's understand the business, go straight into modeling, feature engineering, model training, model evaluation. That would also require you to do data acquisition and understanding. So these all processes are great, no denying. But what we felt at Toyota, that there was something missing. That you couldn't necessarily start from business understanding. A single block for business understanding was not enough. We needed to do more. We needed to align more stuff. So we sort of built a very similar data science process at TMNA that's sort of working for us. So let me introduce you that process. So we call it. So okay, before I introduce the process, let me help you understand like what we did to build that process. So obviously we studied different data science processes, which I was following some of those before Toyota as well, and at early days at Toyota also. He said that let's take those data science processes. Let's put that design thinking elements. Then let's go back to our roots and see how data science would happen if we were to think from a Toyota perspective. And we sort of built a process. It's called init mods. And I'll just quickly introduce that process. So it starts with, this is the process. So it has like 8 steps. The first 2 steps are called ideation and nemawashi. And then you have exploration, transformation, modeling, optimization, and then you also obviously have deployment and scheduling. Scheduling, and almost you can think in terms of downstream system integration and so on. So what's unique about this process is, if you really look from this perspective, it's easily understood, and it's no different than what most processes would tell you about, except for the fact that we have, when we go into the details about optimization steps, there are certain things that we do to make sure that it can work in the setup that we have. The ideation and nemawashi are those steps that I'm going to go a little bit more detail to, so that you get an idea of how do we even go about building a use case, right? I probably won't go in too much detail around these aspects, because these are well understood topic, but if you have questions, I can definitely answer that. So if you're really looking at where we have implemented certain, let's say, design thinking, we implemented a lot of those design thinking principles in the ideation nemawashi stage itself, which I'm going to talk in the later slide. And obviously, third away mindset was, and mindset, and not just the mindset, but the whole approach, what do you do in those steps is there in all these, across all the steps. And these two are heavily influenced through a standard data science process that exists, right? So that's how it is. And if you really see INETMODS, it's nothing but it stands for the first letter for each of the steps, right? So it's a INETMODS. Okay, so with this process, we have a lot of different parts using this process, building model, deploying stuff, and getting back to our stakeholders. So let's talk a little bit more about the ideation and nemawashi, because this is one thing that we tend to go and set the expectations with our business stakeholder quite a bit. So what happens, obviously you have a business, if you have an idea related to data science, what they typically do, we have different intake mechanism by which a certain data science team would learn about the idea. So we'll discuss in terms of what it is, what it needs to be, and things like that. Now, one thing that we do in that discussion, we don't never try to be, we never tend to be a business person as a data scientist. We are the advocates of the data. So while in these discussions, we tend to, again, this is a little bit old slide. So you can think of, you have different tools. So we tend to make sure that during these discussions, we are able to do some quick baseline analysis itself. Those are happening either before the meeting or maybe after a quick learning about it, and it's an iterative process. So we're learning about, we're pulling some data together quickly. We are continuing our discussion with some facts and figures, which at times our business stakeholder may not be aware of. And this goes back to establishing the JKK and that mindset where if you don't know your current process, how are you gonna improve it, right? Similarly, if we need to build a model for a certain process, we need to understand how that process works and how the data, what are the different KPIs that are being tracked at different steps in that business process. And those are interesting conversations that are happening with different stakeholders, and often they learn a lot about their own business through data in these discussions. Then we define goals, right? And then obviously we are doing also the data science feasibility with respect to the data that we've seen, the historical stuff, and what is typically possible from data science perspective. then we tend to align with them that, hey, this is how it's going to work out. And we are going to try to improve your, let's say, baseline by a certain percentage. This is what you can expect. This is how you can expect to utilize the outcome of the model, right? And then if you're not aligned, then we go back to goals again, and then we do this. And there's another culture at Toyota that's pretty common. We tend to write all business case in a single document, in a single paper, and that's A3 is the size of paper. And it's very common at Toyota that you can build a huge business case just on a sheet of paper. And obviously you have a template for A3, so that's what the team is doing. But the idea is that everything should be visual and it should be in front to have that discussion. There shouldn't be too many slides if you're sort of documenting the use case, right? So that's something. And A3 is not just like a fixed pattern; it's a guidance. So if you can communicate your idea in a single page using certain template that works for you, and if you are able to answer the different questions that typically would come, that's perfectly fine. So yeah. So again, I think okay. So there are a few things that we make sure we tend to do. These are the guidance for the product managers when they're interacting with the stakeholder. Simple stuff, nothing amazing. The goals, we tend to make it smart, specific, measurable, achievable, realistic, and timely. And when we are engaged with the stakeholder, we tend to make sure that we can do some of these quantifications really well. Yeah, and some I'm not going to go in details, but when I send out the slides, it'll be there so you can actually take a look. So now, having talked about data science at Toyota and how process works, what kind of use cases we do, and the team structure, let's dive a little bit more into the customer journey with data science, right? This is work that happens within the customer and marketing data science, which I am responsible for directly right now. So let's try to understand the journey of a Toyota customer. And again, the journey of Toyota customer, as we see it, is through, it could be too much to put on a slide. So I'm trying to put a very simplistic version of our journey of a Toyota customer. So it starts with somebody, that idea that, do I need a car, right? When you are asking yourself that question, then you're already part of our journey process, right? Then obviously, and it's a question that comes up: which car is best for? Which car is best, right? They ask that question: which is the best car to buy? And then they sort of overlap that with, is it still the best car for my needs? Then there are a lot of research that happens, then trying to find the right car, right? And then this question of, can I afford this car? And then the question is where to buy the car, right? Yeah. There's often this, am I getting any deal? Is deals important for me, or is the car more important? Am I able to find the right dealer? You know, there are so many dealers around where you live, and there is so many options. So where do you get the car? Are you able to get the right level of trim and the right dealer, or you have a good dealer, but then you don't have a right trim? So what do you do in those scenarios? You actually go to a different dealer to get the trim, or what exactly you do, you know? Then let's say if you buy it somewhere, then you are registered as a new owner. You start engaging with the brand as an owner, right? Which means that you would be filling product quality and other surveys, right? Which we learn about the product through you. You might be making a lot of visits at the dealership for, let's say, Toyota Care in the beginning, but then over a period of time, it could mean that you could be going for the dealer for a different kind of repairs. You could be going to the same dealer where you bought it or where you live, or you could be going to a different dealer. Maybe your home, where you live, the dealer which is close to your home and the dealer which is close to your workplace, they're two different dealers. I mean, maybe it's optimal for you to get service done while you're at office or you're at work, right? So there are a lot of decisions that an individual needs to consider when through different aspect of journey. When you've had a service repair, do you go for the same dealer or other dealer for repeat service, or what exactly you do? And over a period of time, you're gonna need a different vehicle. Which car you need, which vehicle you need, right? So this is a very simplistic version of the kind of questions that as an individual anyone would have. So if you think from our perspective, this is how we see it. The first row is all around shop. The second one, we think it's around buy. And then third is own. So we have a lot of our initiative called Shop by Own. And there are different programs that we have which tend to intervene with the customer at different point of the journey. Obviously, there are a lot of stuff that we don't know about customer, and customer tend to be anonymous during the shop phase and the buy phase. But at Own, we tend to know a little bit more about them as they're interacting with our products. So let's take a look at the example use cases within shop. So when you're in shop, then we could be thinking who we can market. We can market to those people who are considered hard leads. And then we could also market those are probable leads. I won't go into too much details of the hard leads and probable leads, but you can almost think of hard leads as someone who has mentioned that they're interested in buying a vehicle in the next few days on our different places where we collect this information. One of those in places we collect information is our website, toyota.com. Then the other question is what to market. If you know who to market, like what to market. So there is that kind of modeling that are done. Then how to market, like do you do a recommendation when they are on our.com? Do you make a recommendation while through email, phone call, media? What is the best channel for us to be marketing? Similarly, when they're in the buy phase, and again, these are example use cases, there are a lot more. So within the buy phase, you have which trim and color to recommend. Yeah, because at the end of the day, customers should be able to relate with everything that they're being recommended to. What incentive to offer? Cash, APR, or there are different variation of cash and APR. We currently don't do too much on this side because we don't tend not to differentiate between individuals, but we do definitely have different incentive in different regions and different markets. Which dealer will be most optimal based on where you live, where you work, or based on what your needs are? You should be recommending a dealer that would have everything that you need and should still be optimal for your needs. During the own phase, who we would like to predict like who is likely to return for a service, right? We'd like to know what parts of service a vehicle would really need in the near future. who are loyal, who are advocates. Are they loyal and advocates about our brand? Are they loyal and advocates about our dealer itself? Who could be defecting? Who are likely to buy again? And what customers are engaged? What are types of these customers? Right. So these are the example use cases that we have in the own phase of the customer journey. So if I were to really look at a very simplistic view of how we conduct our experiments, this is what we do. So let's say we have some input data. Then we sort of go and build a feature store using data pipeline. We tend to do a lot of those in Spark and Databricks. And these feature store are then useful for running various experiments, right? And what I'm trying to convey here is that for across all this input data, we might need to build features, let's say at a consumer level. We might need to build a feature at a vehicle level. We might need to build a feature at a customer and vehicle level, right? You might need to build certain things at the dealer level, how well the dealers are doing, what they're missing, comparing dealer ranking, performance. Then we would also be interested in building features at different kind of events. So there are different kind of feature store. We tend to call them ADTs. ADTs is a short form of analytical data transforms. And these ADTs are then building blocks for running all kind of experiments. So ML experiments can be based on these feature store. Then obviously we use a lot of Python-based stuff, PySpark, TensorFlow, and PyTorch, and everything that's available. And this is how we run our experiments. But what do we do in deployment? So let's take a look at that. And then one additional thing as well, when we are running these experiments, since we are running a lot of experiments, they're being done by different data scientists. We have sort of a standardized notebook for these experiments, things that they must be including. Again, those are guidance, but if there's an experiment that doesn't warrant certain steps, that's not needed, then that's perfectly fine. Let's talk about deployment. So obviously, when you're building a data pipeline, you will deploy them. So I'm not going to touch upon the deployment aspect of the data pipelines, but let's talk about after you build a model in, let's say, a notebook, and if you followed all the steps of the standard notebook, then what we actually do during a deployment, we sort of have a data science container. That's essentially nothing but a bunch of packages in a Docker, and it's a container where you can put your code and sort of deploy it. So I won't go into too much detail there, but let's say you have this data science container which has the ability to put all the different packages that you would need, and then it sort of knows how to scale on different needs and all. Then as a data scientist, you're taking your code and sort of putting different scripts, like train scripts, you'll have transform scripts, you'll have predict scripts, you might have a consolidation. So let's say, imagine you are building a lot of different models, and then you want an output which is sort of consolidated across different models, or you're sort of building a decision engine on top of your model. Then you can use the consolidation. And this is what you basically put your scripts in. Then you get an output from this script, and then we build sort of an integration pipeline, which basically is developed thinking the end customer in mind. So we might have a customer where they need the output in their system. So it could be a batch delivery. We might have an API endpoints where they want to consume at a, let's say, at a vehicle level or a dealer level, right? So those are things that are exposed through API endpoints. Then it is possible that you'd want to, let's say you have a customer segmentation stuff, then you'd want to have the outcome shown as a dashboard. you might have we might have a predicted outcome that is needed across a different product. So we sort of enable that sort of integration through these integration pipeline. So having talked about the deployment process, let's talk about some of the example prediction that we're doing. I know we talked about the use cases across shop by own, but some example prediction. So if let's say if there's a Toyota customer, we tend to predict some actions across the awareness, which are depiction of awareness. So this is where this is helpful because if we know a certain customer is going to respond to a campaign response, then we can sort of use that to communicate them. Similarly, there are a lot of consideration phases of buying. So we do some prediction on that side as well. Purchase side, how much they should be spending and things like that. Service side, which parts, which service, loyalty aspect, advocacy aspect. Are they recommending dealers? Are they recommending brand? So these are some example prediction that sort of happens as a part of the customer journey. I talked about customer identity when I was showing the deployment or the feature store. So if you really think about the features, the kind of data that we're using for building this feature store is the transaction that are happening at the dealership, the survey responses that our customers are filling for different kind of survey, the demographic data, the digital interaction that are happening on our website, social platform, email marketing response. And these are the feature store that are input for hundreds and thousands of experiments. And if you really see from an orchestration standpoint of the deployment, this is a simple one, which is showing you check all the data that's needed to even build the feature store. So you have a job that check the readiness of all the input data. Once that is done, you sort of have the feature store, the data pipeline running to create the feature store. Once that is done, then we have a lot of pre-checks to make sure we are running our ML pipelines. Once those pre-checks are done, and then you sort of have those model run. And this particular model has two different point of integration. One is for a dashboard that's needed by some of the stakeholders. And another one is a downstream integration with our marketing system. So that's where this is going. And this is a single orchestration using Airflow. And if you really look at this one, within this in market, I talked about the train, transform, and predict and consolidate. So it's basically showing the different blocks of train, transform, predict, and consolidate. And then, so this was all around the process of doing certain things. I wanted to spend maybe 5 minutes on some of the behavioral insights that would be interesting. So when it comes to behavior with time to purchase since being a lead, people could be a lead for a while. So this is how it works. So you have a lot of users actually who are lead, and they sort of buy a vehicle by a certain time, right? So let's say what we have really found that till 90 days, this is what will happen, right? The number of people would be increasing with time. It is probably very different from your consumer products, where it'll be other way around, where the more time it happens, meaning that your customers has gone away. And then same thing that we see after 270 days. Very less people who are actually buying vehicle after 270 days. But between 90 and 270, we have all kind of things that we've seen. And what we have realized that is the quality of lead that we're getting from different channels. That's basically guiding a lot of those trends. And we still don't understand what really happens between 90 and 70 days. So there's a lot to be done there. A lot of people, they are lead just for, they fill different forms. They will pose as a lead, but maybe they are not lead. So another interesting aspect about our business is you would expect, so in the first 2 years, right? I mean, you have Toyota Care, which means you go to the dealer for your regular maintenance, and then you don't have to pay any money. But then over a period of time, your visit to the dealer actually drops down, and it's an industry problem, because when things are free, they're going there. But then when things are not free, they are not inclined to go to the dealer, because they can go to Jiffy Lube, or they can go to Discount Tire and other places where they get those specialized services. So we have a lot of programs that sort of try to improve that situation a little bit. So we've started noticing a trend that this is a trend that we would like to have, because over a period of time, you need more services to keep the vehicle. And after a certain number of years, your number of visits shouldn't be increasing at all. So this is one aspect which is sort of interesting. This is again something that we see as a opportunity, right? So if you see customers spend on vehicle purchase, so you'd obviously believe that if you're buying more vehicle, then you're sort of loyal, right? There's this very simple relationship that exists. But if you really see customer amount spent on repairs, this is how it works. You are probably loyal up to a certain point because you keep visiting the dealer for a certain kind of repairs. But over a period of time, if you have to spend more money on your vehicle, then you're probably not going to be liking the brand that much. So obviously, we do a lot of these studies to find the optimal range. So we don't necessarily see customers spending with us on repairs as a loyalty thing, even though that means money for part sales, money for dealers. We don't necessarily see that as a sign of a customer loyalty. So there's a lot that we actually do in this area, and we continue to do more work on that side, because it also depends on the vehicle. It also depends on your driving habits, and we're going to be putting more efforts in this direction. So yeah, I'm not going to go into this. So I'll just wrap up with 5 more minutes. We are hiring for many roles in data science across different pods. You can find more at this. I'll have this link when I send out this presentation. So yeah, that was all I had. Forward it to you, Jen.
Thank you so much, Ram.
Yep.
We have a lot of really interesting questions, and I apologize to folks if I don't get to your question, but let's spend some time. Let's dive right in. You ended on behavioral insights that you're seeing from about your customers going from leads to drivers. Has the experience of the last 2 years in the current pandemic changed sort of fundamentally any of the profiles that you're seeing?
Absolutely. So we've had inventory issues, supply chain issues. So what we are noticing now that the number of leads that we have used. So there have been 2 periods basically. There's a COVID period and then there's a recovery period. So obviously during the COVID period, there were very less leads. There was a lot. Our dealership was closed, but when it opened and during the recovery period, we have seen more and more leads than what we can support from inventory perspective. So right now, it's really been about how do we rank our leads? How do we have the leads? Because any of the leads, they're a prospective customer. We still want the best experience for them when it comes to with our brand. So there is a lot of need of data science to actually direct these leads with the right channel, with the right dealers, and at the right time. So yeah, it's when it's been a lot of work for data science team in that space.
It's an interesting space, and I think that obviously the overall takeaway is that consumer habits have changed.
Yes.
So thinking a little bit sort of broadly at Toyota, how does Toyota drive data governance as part of your teams and pod structure?
Yeah, so data governance is key to anything that you do at Toyota. So during the ideation and nemawashi step that I talked about in our data science process, one of our key stakeholder there is data governance and compliance team. So we take it very seriously because we want to do the right thing by the customer. Obviously there are compliance like GDPR, CCPA. Even though when we did the CCPA, we sort of implemented for the entire country, not just California. And there are certain aspect of the data that you cannot use for a certain kind of modeling, and that's a part of the education that we do for everyone in the data science team. Things that they can do and things that they cannot do. A lot of the data sets that are not available for a certain kind of use cases. So the reason we sort of created a pod structure within our data science team so that we can control the access of data for a certain kind of use cases. And that's managed that way. So we have security implemented. We have CCPA integration with all the data science output. We have the different regulations like RTD, RTO, those kind of stuff as a part of our CCPA that we follow strictly. Yeah, so very much compliant. The data governance team is another pillar in our data analytics broader team.
Yeah, it makes sense to think about that from a central point of view, right? Yep. So this is a little bit related to your structure in that same way. I think the Toyota way is well documented in business schools everywhere, right? And so, you're famously about quality and being lean, right? Mm-hmm. And so thinking about data science, so someone has asked, when it comes to data science, how do you apply lean management? And have you built any tools or used existing tools specifically to think about quality and also being lean?
Yeah, absolutely. So if you notice, some of the feature store that I was talking about is about being lean. Being lean is not just about being lean is about many things, right? So one of the ways we take advantage of having a lean structure is when we are creating these feature store, these are independent jobs. So, and these are, they're like hundreds of these pipelines that exist that power thousands of experiments. So you don't have, when you're running an experiment, you almost have to never think about building a feature store unless you're going to be working with a new kind of data sets, right? And this is also helping us avoid a lot of cost, like cloud cost, compute cost, and also make sure when there is a point of failure, right? Back to the JKK and TBP stuff, we are able to handle that as a part of a certain job itself and not worry about a particular job. And the reason it works really well, because in modern day orchestration, you have airflow and Kubeflow kind of stuff, which can orchestrate different jobs. So that's something that we do. And then the other thing that we do as a part of the data science process, I talked about ideation and nemawashi. So we don't sort of engage the entire team unless we know certain thing about the use case itself. So that helps us make sure that we are still lean in data science team. We don't have like a big data science team. It's very difficult to maintain one. It's very difficult to keep them motivated as well. So we sort of try to engage our SME knowledge on different aspects of our business function with the stakeholder and all. So it's built in our thinking process. I don't know if that was the answer you were looking for, but it's right there in our mindset and processes and everything that we do.
Yeah. I'd like to shift a little bit to thinking about the customer journey. And I have a question, which is, you said that you begin your customer journey at, do I need a car? And how often do you think about the step before about converting non-car owners to car owners? And do you have any solutions in that space?
Yeah, absolutely. And this became quite common during this COVID time, because we found that there are many customers who never owned car. They were using trains and all. They were coming into the market and they were sort of buying first car. Um, Obviously, we do a lot of we can do only so much, because we don't know about anyone if they have not been our customer prior. So the idea is that the websites that we have, Toyota.com and all the 1500 dealers website, uh, if a user wants certain information, like if they're requesting a car, they're requesting to go to a visitor dealer, or if they have bookmarked or saved a certain vehicle in their profile, then we are able to route it appropriately, right? For first-time customers, what we really found, and this was probably in our NY region. When I said NY region, it means like a lot of the eastern states. Um, like we have 12 regions, NY is one of them. So we found that in that region, there were a lot many first-time buyers who just wanted to have that comfort of having a car that they can use to commute. Yeah, so we can do very less about that. Obviously, we have a product-based marketing that's happening, a lot of ads that you see typically from Toyota. Those are also geared toward first-time buyers as well. But from a very data-centric way, the most we learn about is through our leads outlet that we have on different website and other places.
And so I'll finish on a couple of fun, I think, future questions.
Yep.
Where I think maybe it's been a long inflection point, but I think that we're in this space now thinking about connected mobility and connected vehicle to everything space, right? And so we have a question here, or two related questions. What role do you see the Toyota data science team playing in those spaces and use cases? And what are the biggest challenges that you can foresee? And how can data science continue to be a part of the solution to those challenges?
Yeah, that's a very good question. So we actually started a new company 4 years back or 5 years back. It's called Toyota Connected. So we have Toyota Connected in each of the regions, right from Japan, North America. So it's a Toyota Connected North America. It's also in Plano. It's nearby TMNA. And we have a lot of close collaboration with that team. So when we think of mobility, we just don't think in terms of vehicle itself, right? There are other initiatives from Toyota that's also pushing the boundaries of mobility, because mobility for us is mobility for all. We have a lot of vehicles that are designed for different kind of needs. That's one area. The other area is obviously the data collection that's been happening right now through telematics and all these kind of stuff. Right now, it's very costly to actually keep collecting the data from the vehicle and sort of build intelligence. But we're doing some work there, and we want to continue to work in that space, because obviously, just because you have telematic services enabled, you can't really charge customer that amount of money. So I see a lot of engineering. Like when I say engineering, I mean a lot of data engineering work that's needed. A lot of data science work is needed. We also think that if we use that data intelligently, then we can learn about the driving behavior of the customers, which can help them to get a better quote on their insurance claims. Some of the work that's happening on the area. It also helps them understand their own behavior. Are they putting the brakes too harsh? Are they speeding at different time? What is the acceleration? And I believe these are some of those information that's gonna help the driver become more aware of their own habits, which otherwise they may not be aware.
That's
So
fascinating. You're thinking about how you might nudge driver behavior
yeah,
in that way.
yes. And the key thing is to make this information available to them so that they can actually take their own decision, right? So these are some of the things that are happening, and obviously we recently launched like 6 months back. We launched our own new infotainment system, brand new. It came out with NX, Lexus NX, and it's going to be rolled over to most of the vehicle in the near future, including all the electric ones that we have lined up.
Well, I have to say thank you, Ram, so much. And thanks to our participants for all your really thoughtful questions. I'm sorry that we couldn't answer all of them today, but we're over time now. So I'm going to close by saying this is our last industry seminar for this term. However, it's not our last event as we finish celebrating our 5th anniversary here at the Harvard Data Science Initiative. So I'm just going to mention a couple of upcoming events. Hope folks will join us for them. We have a panel coming up on April 20th, moderated by former CEO of Goldman Sachs, Marty Chavez, on technology, platforms, and the relationship with regulation. And on April 26th, we have another panel featuring speakers from data.org, from McKinsey and Amazon Web Services on data science for social good, including what role industry can play. So hope you guys will tune in. With that, I'll thank Ram one more time and bring the session to a close. Have a great afternoon, everyone.
Yeah, thank you all. You've been lovely audiences. Thank you. Bye.